Hello everyone. What we're going to talk about is the definite integral involved in substitutions. So we're going to look at substitutions with definite integrals. So what we mean is that we have limits of integration of some function, and this is telling us that our interval that the integral is valid for is from a to b, and this would give us a numerical answer. What we want to do is work with substitutions to talk about our substitution space. So in a substitution, I'm going to be rewriting this so that I have my limits of integration of f, and I'm putting into f some function g of x, and that's multiplied by g prime of x. And this is the same format that we used when doing substitutions on an indefinite integral. And what this part created for us was some function we're going to call g of xu du. But what we've done is this space was the domain and the interval for x. So the interval for what this is valid for is going to be in u. And to find u, the function we use for u translates all of the points inside the interval. So our interval will be from g of a to g of b. So we have to translate the interval, and I'd say this is an x space, over to u space. And so to do this, we can plug in values, and this will remap all points in the interval for us. So let me scroll down here a bit, and let's look at an example of how we can do this here. So we're going to use the integral -1 to 1 of 3x squared times the quantity x squared plus 1 dx. Now this is the integral we looked at when we first introduced substitution methods, and in this case we realized we didn't have a clear antiderivative for this. But if we took this section here and, oops, I'm sorry, that shouldn't be x squared plus 1. That is x cubed plus 1. All right, that's the integral we did in class on Tuesday. But if we take this section and we set u equal to x cubed plus 1, and we differentiated with respect to x, we found these pieces here. And so with the substitution, this becomes u to the 1/2. Right? Here's u. Square root will be the 1/2 power. And then in 3x squared dx is du. But we need to remap from the x space to u space. And we do that by treating u as a function of x. And so if I plug in the upper limit, 3 times 1, oops, not 3, plugging into u. So u is x cubed, so 1 cubed plus 1 is equal to 2. So my upper limit becomes 2. And my lower limit, so I get negative 1 cubed plus 1, which is 0. And now I've remapped this definite integral from x space to u space, and I can now use a power rule. So this would be u to the 3/2 times 2/3. And now I don't need a plus c. I can evaluate this from 0 to 2. And so in evaluating that, I'm going to look at 2/3, 2 to the 3/2 power, minus 2/3, 0 to the 3/2 power. Well, that goes to 0, so I can focus on this. So 2 cubed is 8, and then I take the square root of 8. So, let's see, 2 cubed is 8, square root of 8 is 2 root 2 over 3 times 2, or 4 root 2 over 3. And so the substitution method works for definite integrals as long as we remember to remap the interval from x space to u space. All right, I'm going to make these videos short, so I'm going to stop here and I'm going to continue the lecture in the next video.